Afternoon, guys. So my name is John Painter. I'm a solutions architect with Source Group.
My name is John Spinks. I'm also a solutions architect. Sourced is based out of Sydney, Australia, although we're just starting to move into Toronto, so we've got a bit of a North American presence. We've been working with enterprises for the last four and a half years, primarily around Amazon Web Services and Puppet. We've been Puppet Labs partners for about the same amount of time. We're going to talk about some enterprise architecture today.
Cool. So basically what we want to do today is we're going to run through a series of design patterns that we've basically put together over the last 4 or 5 years with a combination of Puppet Enterprise and typically Amazon Web Services as a platform. So it's kind of a few key architectures and learnings as we've evolved. These are all productionized architectures, productionized platforms that are used in-site across the enterprises traditionally in Australia. So it is an in-the-trenches view of what we've deployed. So having a look at one of the first solutions here, one of the first solutions was having a look at a telecommunications provider in Australia. So, oh, sorry, my mistake. It's actually, the first design pattern here is actually a multimaster solution for a investment bank out of Sydney. So they really had 2 primary goals, and that is, relatively organic experience with adoption of Puppet. They wanted to consolidate and standardize all their operating systems and bring them back to a point of truth. They basically want to, reduce their configuration drift using Puppet Enterprise as a platform, and they wanted to introduce, obviously, change control processes and programmatic change control processes into their infrastructure. So these are relatively organic goals that a lot of first-time consumers of Puppet would have inside their business. And just having a quick look at this pattern, it's about 4 to 5 years old at the moment.
Okay, so this is the global multimaster. The client had a unique kind of distributed environment. It's a global investment bank based out of Australia. And I guess the biggest challenge there was it was very distributed. So this is a kind of a high-level view of the architecture. What we ended up doing was creating a puppeteer, which is essentially a puppet master that manages puppet masters. And as far as the NC went, we used LDAP, which was quite robust in the environment. And it was kind of a backbone for the whole platform. It was already distributed and it was already replicated for us, so we just put our ANC data into that. Each region had a HA pair of puppet masters and a puppet console at the same time. We did that mainly because the puppet reports were getting very large, getting shipped across the world back to a central point. So we did lose that central point of view on the reporting, but we regionalized it. One of the side benefits of having a central puppet master managing other puppet masters was that we had a central point of control for the code base. And essentially, we've implemented a follow-the-sun code release model, which we'd start off in Sydney, and then through Asia, and then through Europe, and to the USA, eventually once we were outside of business hours. And this allowed us to put more control gates in. So not only were we doing version control deployments inside of Sydney, but that code was actually getting pushed out outside of business hours around the world, and allowed us to stop if there's any problems as we went. So
really, a relatively simple goal from Puppet as a platform. So obviously the key thing there was to bring everything back to a central point of truth. And obviously that central point of truth was sourcing a lot of different regions and a lot of different areas and a lot of different time zones. But ultimately they came back to basically a central point of truth that had a viewpoint on where the infrastructure is. So it wasn't just a technical outcome. What actually happened out of that, and I'm sure this is the experience of many people who've put Puppet in their organization, is it became a source of audit data and governance for that organization. And they were able to really improve their governance processes and the data they had about their applications by leveraging Puppet that was spread across sort of a global platform. The other thing obviously was the simplified point of control so they could automate changes out using Puppet as a framework. So this is a really important piece is around the governance, and especially when we're working with financial services where they're working in heavily regulated environments and they have to be able to basically produce a viewpoint of their applications at a point in time very, very, very quickly. So
the takeaways on that environment was that we think LDAP's a really great ANC, especially when you have that backplane already replicated around the globe for you. So we set and forget. We've got to be careful about Puppet reports. Again, this is 4-year-old data now, but the reports were getting quite large. You can use a Puppet master to manage other masters. They work well. And ultimately, and you'll see this repeated over and over again, is that version control is critical as a basis for any kind of change control process.
So moving on to the next major engagement. So we'd basically gone to this multi-master scenario. That was relatively traditional infrastructure. So that was a bunch of data centers they owned. They had a lot of infrastructure, physical infrastructure, network switches, servers, all that kind of stuff. The next engagement, and this is back in February of 2012, was a telecommunications organization in Australia who basically wanted to consume Amazon Web Services as their compute platform. So they kind of had a few requirements. So of course the first thing, they still had this desire and this requirement to have a point of control, to have a single source of truth. So again, they were a regulated environment, not so much thin services, but they still had a lot of security regulation and a lot of compliance requirements around visibility into the infrastructure. But they also wanted to orchestrate. So obviously, because it was Amazon Web Services, they wanted to sort of investigate some of the automation, some of the tooling around that. And the key requirement here, and the reason we couldn't just go cloud native tool sets on everything, was they wanted to have portability of the application back to the data center at any arbitrary point in time. So obviously that's an ideal fit for Puppet.
Yep.
So this is the second key design pattern was basically Puppet right in the middle of the Amazon infrastructure platform.
So back in 2012, we investigated how Puppet could get in that workflow and really be the source of truth as far as making compute instances inside of Amazon. And at the time, Puppet Enterprise Edition had Cloud Pak baked into it, which is essentially a wrap around the fog library. We quickly learned, though, that there was only EC2 support in that, which is going to be a limitation for us because really the enterprises were demanding VPC at the time. So EC2, as you know, the default used to be that you'd go straight into EC2 raw, but Amazon's now decided that that isn't going to fly, and they're going to move to a VPC everywhere design. So ultimately, this would have been the solution that the customer would have got if we'd stayed on that.
Yeah, so just talking to the changes to the Amazon platform. So Puppet Cloud Pak at that time was basically had awareness of the EC2 compute platform. And at the time, Amazon really only had the EC2 compute platform in terms of like the ability to provision servers and the ability to provision storage and load balancing. Then obviously, Amazon basically made a step change in their thinking, and instead of nodes being provisioned onto public net as part of EC2, they essentially launched, and this was kind of in mid-2012, they launched the VPC service, which is a virtual private cloud. And that's the ability for customers to run servers and infrastructure, databases, storage, all that kind of infrastructure and resources inside private IP space and inside their own private IP allocation. So this represented a step change in the security of the platform, and all the customers are obviously very keen to consume that because they could basically rig their corporate data centers via VPN directly into a private environment that was actually running up in Amazon. So this obviously required an uplift of the Cloud Pak module, but also keeping Puppet right in the middle of that orchestration piece where it's the thing that's owning the actual orchestration of the Amazon servers themselves.
Yeah, so okay, we uplifted Cloud Pak, so it understood VPCs. And this is kind of the high-level workflow that we ended up with. So Puppet would create an instance in Amazon, and once the instance was booted, it would bootstrap the agent onto it. It would classify the node inside of the console, and then the application would get deployed. We went fairly complicated on some of the applications we're using. We did Hadoop, HDFS, Solar. So a lot of the services that were already available as an Amazon service, but we're really bound by the client's requirements to have portability and arbitrage between Amazon and their internal data center. So again, ultimately, Cloud Pak now supports EC2 and VPC, and you can use a Puppet Master as a provisioning tool within a programmatic environment. So at the back of that engagement, we were invited to speak at PuppetConf 2 years ago. We spoke about using Puppet as cloud glue, and we took the learnings we had from Cloud Pak and we extended it essentially for the event. And we extended Cloud Pak to understand Rackspace and Joyent. And the demo we gave was basically using Puppet to provisioning compute and bootstrap on those 3 cloud platforms. So really taking Puppet and making it cloud aware.
So talking through the next major engagement, so kind of where we're at right now, and this is kind of the last time that we presented at PuppetConf, is that we've got Puppet right in the middle of this orchestration piece. So Puppet master is actually the thing that's provisioning services and is launching nodes and right in the middle of that orchestration piece. So the next thing we did is we basically went to a financial services organization, and they also wanted to run all their stuff on Amazon. But they had a slightly different take on it, is that they were ready to make the journey to basically like an Amazon native workflow. So they didn't necessarily have the requirement whereby we have to be able to move the application back to the data center immediately. They were happy to basically start consuming Amazon native services and Amazon native frameworks to power their applications. So specifically what they were looking at is they were trying to utilize some of the cloud native services such as auto-scaling, auto-healing, application stacks, dynamic provisioning, all of those types of things. So that was kind of their requirement, and it was just a representation of the maturity of clients moving into cloud native workloads and cloud native applications. The other thing is that we still had, because they're a financial service organization, we still had this government requirement. A regulator can walk in at any point in time and they can say, we need to know the state of all your operating systems at any point in time. So we still needed to maintain that regulation framework and that governance framework and compliance framework over the top of this cloud native transient infrastructure.
So the environments we spoke about so far, so the two design patterns, were really addressing standardization, reducing configuration drift, allowing us to consolidate down and be more efficient in what we do. As we move forward now in some of the discussions, we're going to look at moving away from stateful compute and more to transient compute, and then looking at how we can align the two and have that ubiquity of control across the two.
So the next design pattern was really looking at the time, of course, this is winding back a little bit, how we got all the features of Puppet, so all of this configuration drift management, all of this visibility into our applications and our operating systems via Puppet, but still letting Amazon do its thing. So let Amazon scale, let Amazon do all this transient sort of activities. And like one of the learnings out of this is just before we dive into the specific architecture, we just wanted to discuss a few of the techniques that we've been using with these customers and why cloud computing basically really did represent a fundamental change and a fundamental shift in how applications were being delivered and then how they were being run. Okay? So the first real thing, of course, as we know, is that one of the big changes with cloud is everything's become programmatic. And we're not just talking about programmatic in terms of, there's like an API that I can hit to provision service, right? I think that's a relatively well-known thing. But there are actually entire languages and entire frameworks that let us substantiate application stacks via a cloud-native language. So we're talking here about Amazon CloudFormation, where we can essentially say, this is what I want from an infrastructure platform. I want load balancers, and I want storage, and I want compute. But it also goes up the application stack, and it starts provisioning applications, starting services, laying down files, et cetera, et cetera, et cetera. Now, what this really let us do is because we basically had this declarative framework that we could use as a cloud-native declarative framework, is it really let us innovate and experiment with the application lifecycle pieces. So it wasn't just about, we can provision servers, it was actually getting right in the middle of the application lifecycles. So a traditional enterprise, and most of the traditional customers up to that point, we basically have an app running on a server. So, you've got application, my app running on a server, and what you'd do is you'd reach in with Puppet and you'd go and update that application on that existing server. Well, what we can basically do now is instead of interrupting that application, instead of managing that orchestration, instead of interrupting the running app, instead of introducing risk to that platform, we have a really simple framework and we have a really simple set of technologies that just let us build a whole new copy of that entire application. So I'm talking here about load balancing, storage, networking, the actual servers, and the actual application itself. So this is kind of like a stack methodology. So instead of introducing risk on a running app, we just build a whole brand new copy of that app, obviously with the new version of the code and the new version of the application on there. Okay? And then we leverage DNS over the top of that. So instead of interrupting the server, we basically just roll DNS onto the next stack. So this is kind of an application lifecycle. We've defined an application lifecycle. And the great thing about that, and one of the key innovations here, because that's not particularly that exciting, the key innovation here is that because we have this lifecycle where we can basically say, here's my servers, my load balancing, my infrastructure, and here's my app. And again, because it's 100% programmatic, and we all understand that, is that it's absolutely arbitrary for me to now run that lifecycle as often as I want on any kind of Git branch system that I care about. So you saw there is that production went from V1 to V2 by provisioning a whole new stack. But in order for me to have a completely discrete and completely isolated copy of my application running, all I needed to do was git branch, and I have that lifecycle being enacted again. And the real trick there is that can keep going forever. So we now have this exploding scope problem whereby we still have the same targets. We still need to have the governance and the compliance and the viewpoints, right? But it's not just the servers that are transient, because that's relatively easy to handle, but it's the entire application stacks themselves that are now transient. And the other thing is, the application lifecycle has been really sped up. So because the risk has been reduced, the business was now happy to start driving those applications a lot harder. Because as we saw, it's just DNS. If there's a failure in that release process, you just roll DNS back to the previous stack. So that update process became so simple, we can drive it a lot quicker. So, Nigel actually said it back in the camp in Sydney, is that 18 months really sucks, but the introduction of that model has really allowed businesses to go from weekly, monthly updates down to hourly. And we have some very large clients with very large apps who are now working with that kind of time frame. So there's another few key technologies that they wanted to utilize as well.
I guess why would we go to the effort and trying to engineer this when we had a good solution that worked? Well, the business wanted the agility, obviously, as John said, being able to roll code out really quickly. But also, if you look at auto-scaling and auto-healing, obviously auto-healing is great. So you set and forget, and you get notified when something's healed. That's great. You don't have to get anybody out of bed for that. But also, if we can align the actual compute requirements against the actual amount of resource we apply to that, our costs completely align as well. So ultimately, what we end up with is basically a cost saving across the board. So that's really where these customers wanted to go. The two requirements of why we wanted to go down this auto-scale, auto-heal route was reduce operational overhead and also get some cost savings. And we see people who go to infrastructure as a service in cloud environments, and they learn this new environment, but they bring along the old processes, and they bring along all the old human costs along with it, and they don't really truly realize the cost savings that they could in the cloud environment. They might just do things the way they did before, same number of humans, same process, but they're just using cheaper tin now. They can go a lot further.
So what we wanted to do is just kind of define the problem space, right? So why did we engineer the solution? Why did we drop it into a bank? Is the problem space we're looking at is that Puppet basically wanted to really have a very, very direct relationship with the server. So the server was this thing, we get the cert and we sign the cert and we approve that server to be part of the Puppet landscape. So it wanted to kind of own everything, like relatively long-lived. So when we start talking about application stacks that might last like an hour, or a dev wants to turn something on and then he experiments and then he blows it all up and he just provisions another application stack because he can, because it's now a completely trivial process. We're starting to look at environments where there's actually hundreds of servers coming at us on an hourly basis, both in production and in development. So that was kind of one of the first things, is this real move to transient compute. The second thing is that these transient instances, because this was all the way down to development, we didn't necessarily need the same dashboard. We have other mechanisms to get that same sort of governance viewpoint without using the dashboards. And what really happened, and anyone who's ever basically got Amazon Autoscale and rigged it against a PuppetMaster knows that within about 5 days, there's hundreds and hundreds and hundreds of dead stale nodes that are never going to exist ever again, cluttering up the dashboard. So it really reduced the accuracy and the impact and the value of that particular component of Puppet. And we just really wanted to simplify Autoscale. So we don't want a complex thing sitting in the middle trying to own the application.
Okay, so ultimately when we look at this, what do we need? Well, CloudFormation provides the orchestration and the delivery of the instances. We then have instance tags providing node definition and essentially becomes ENC. A lot of people have already extended Factor to understand AWS instance metadata, but it really gives Puppet an awareness of what's actually going on inside of Amazon and it relates the two. And then we essentially bundle the manifests and modules centrally. And they can be like RPMs or tarballs. In this scenario, it was actually a tarball. And because we don't have the console, we used Splunk at the site to give us a view of what's going on and give us a view of change in the environment. So this is essentially just a really high-level view of what we did. So we had a version control repository, CI/CD tools. So that was actually Stash and Bamboo. And we're delivering to Amazon S3. And the way we had S3 configured was basically as an HTTP repository. And the instances were configured when they came up to reach out of that repository and check the timestamp on the file. And if it was newer, they'd grab it and do a bunch of activities, unpack it, run their manifests, and basically get the latest check. And then that all got reported back to centralized logging.
So one of the things here that we've discussed, before we move on to the next design pattern, was that the very first customer winding back 4 years basically had these three things as equally important to their business. Is they had to have configuration management because they had stuff just sprayed everywhere. They had to have application ownership, and they had a governance compliance thing. Over those design patterns, those motivations changed. Is we had cloud native languages and cloud native technologies doing a lot of the heavy lifting for us in terms of providing standardized operating systems. The application configuration was also being delivered out of like a relatively complex CD framework, but they now had hundreds of nodes that were coming and going as they please. So we still wanted Puppet to be governing those nodes for us and telling us that they were okay and telling us they were in a persistent state. So the governance compliance problem actually got even really a lot bigger. So the key takeaway is that is, cloud computing was fundamentally different, not just from a technology perspective, but the way they ran their businesses and the way they ran their applications and how they developed them. It was extremely valuable to the clients and anyone who's in this landscape, right, to leverage the native technologies such as auto-scaling and auto-healing. But the problem we really faced is, without the Puppet master there, we were really just reducing, or when PuppetDB kind of got launched in, we really started to reduce our visibility. So that's really what we're addressing with the next key design pattern we're going to talk through now.
Yeah. I guess a lot of customers are moving towards transient compute, whether it's in Amazon or wherever else. But you have to be cognizant of the fact that they've probably still got a lot of long-lived instances back in the data center or elsewhere, and they could be actually using Amazon for both. So what we were trying to do now is bring Puppet back into the mix for transient, and it's obviously still got its value proposition in long-lived instances. So everybody who's on a progressive IT journey right now knows that data builds transparency. It's absolutely critical that you instrument absolutely everything. And even if you don't look at the data day one, if you've got it, you can go back and look at it. So ultimately, this journey for us was now to try and get the Puppet master back in the loop and get it value back from it having a view of application state.
So it's really important, Amazon, the landscape kind of had 2 or 3 different things. We've discussed this transient compute model, which is application stacks and auto-scaling. We also had stateful computers that not every single application was able to go through the CD tooling and go through that kind of transient compute model. Is we still have a lot of applications that have been put on Amazon that are actually long-lived, which is really great because Puppet knows how to handle that. And we do have lots of people who still have significant investments in capital in data centers. So, there's a huge trove of applications that's still running the data center. So this is why we need to uplift Puppet to understand auto-scaling, because basically, it has to maintain all 3 of those objectives and give them all equal treatment. So we basically want to have a look at basically building a Puppet AWS Autoscale broker.
So this was an attempt to uplift the master to understand a bit more about Amazon and understand AWS Autoscaling groups. So we've got a demo for you as long as the demo gods are with us. So essentially what's going to happen in this what you'll be seeing is we've got a Puppet master. It's got a brokerage service that's running on that we wrote. It's definitely not ready for production. And basically what's going to happen is we're going to go from, I think, 4 nodes to 8 in the demo. And the autoscaling group, we will basically change it from desired 4 to desired 8. It will build some servers. The autoscaling group itself will send a notification service with SNS. And that will end up with an item on the queue, the SQS service. And the broker's just polling that. And basically that means that it has to do something. Whether it's a termination, i.e. the box is gone, or it's an instantiation, it has to do something. So. Okay. So we've got a Puppet master here. Let's check my log back in. So we've got a basic setup here. It's not the latest Puppet install, but we've got 4 boxes sitting there, all signed and happily getting checked. We've got a little process here that's ticking over and saying how many boxes are inside of our autoscale group and their IDs, and we can see they're running. We've got a log tailed here, which is going to show us what's happening on the broker, which is what we wrote. And we've got a little script that basically just goes in and changes the desired capacity inside of that autoscale group from 4 to 8. So I'm just going to click that off. Okay, and I'll switch back over now. You'll see that go up to desired capacity 8.
Maybe just make that a little bit bigger. Can everyone read that? That's right. So just talking through what's actually happening there, basically Amazon Web Services, what autoscaling is essentially a group that's wrapped around a bunch of services. So there's like an image, you can see the services coming up now. There's basically an image and they want to launch this image, right? So Amazon Autoscale has this concept of desired capacity. So what desired capacity represents is how many servers Amazon wants to run inside that Autoscale group. So a launch event, what we've basically done is we've manually told it we need to scale out from 4 to 8. Now that usually and typically would have been triggered by an activity such as like a CPU trigger or like a CPU alert. So my average CPU across these servers has reached a certain threshold. I've triggered the desired capacity up to a high number, and then the desired capacity will basically kick in and scale up that group. So what's actually happening now is that Autoscale on the back end, via Amazon, has basically, so what you've actually seen is the message has actually gone to the bus. So Autoscale has a native capability to drop messages onto the bus on a launch activity, and it's basically dropped the message onto the bus, and the broker's picked that up and is now doing a bunch of activities against it.
Yeah. So we've got a couple of activities for a new event on the SQS service. So what's happening now? The broker's basically said, I've got a launch event. So the stages in the launch event are check the master, has the agent appeared? So it's querying the API, the cert API, and looking for an unsigned cert with the name of the instance ID. Once it finds that, it's going to sign it and then classify it in a group on the dashboard. So we can have it assigned to many different groups, but we've got a little, just over here, we've got a group, Autoscale Group 1. What we'll see there is that the nodes will get populated into that.
So what it is 3 primary components. So we have the cloud native Autoscale group, which is obviously maintaining the desired capacity. And the great thing about desired capacity is if that's impacted in any way, so like a failure of a server or anything like that, desired capacity drops and Amazon will step in and provision you new boxes. So that's like the auto healing concept we keep hearing about. The desired capacity is also, as I said, affected by triggers like CPU, stuff like that. So that's like an Amazon native functionality. So Amazon's provided like a hook for us to automate on top of when it's doing its Autoscale activity. The next thing is happening is obviously messaging coming out of SQS and the broker's hitting all the relevant APIs. So it does take a minute because what we've actually done is we've baked the Puppet agent onto those servers, and we're basically waiting for that agent to hit the master and then obviously set up that cert sign request. It's not auto sign, it is actually talking to faces, finding the cert and then signing it on the back end. Okay? So what's happening right now is we're basically waiting for the operating systems to come up.
So we've seen the client's then created its cert, it's reached out to the master, and now the broker's asked the master to sign that certificate. And you can see that it's just classified the node there. It's added it to the dashboard in the right group. So what that does is essentially assign a bunch of classifications to it. It'll now be getting its manifests appropriately. And you can see the last activity there is to delete the queue message. So the broker's done its activity for those nodes, and now it's deleting it.
So the really powerful thing here is the node classification, of course. So it's relatively useless just to assign a cert. It's actually the classification. That's an Amazon metadata service. So we're yanking that out of the Amazon metadata tags. So that means we can support any arbitrary number of Autoscale groups. All it is just which tag's been applied to that particular service or that particular node tells us which Autoscale group to drop it into inside Puppet.
So I'm just going to refresh this, and what we should see are a bunch of nodes in there now. And basically we've got to wait for them to run to get the first report. But while they're doing that, I can switch over.
So obviously the fact that this is all logged and instrumented, we can also do higher level dashboards. So obviously we just utilize Splunk here to essentially provide like a business level view of what's going on. So we're now getting like really, really deep transparency across our stack. It's not just like a technical event. We're now understanding the application lifecycle, the application requirements. So we're seeing the fact that here's a Amazon native technology requesting a scale event for whatever reason, like whatever trigger you decided to put on scale, whether it be time or load or whatever. And we can build a business dashboard saying like, this is how often you're scaling, these how many boxes you're chewing through, et cetera, et cetera, et cetera. So it's a really nice piece of visibility you can provide for the business. So those should basically now been rigged in against the, and obviously some organizations think that 200 scale events is busy and some organizations think thousands is busy. So we've got the 8 nodes in, and obviously those boxes are now basically signed and waiting for the agent to kick off its first initial run. So this isn't particularly tricky, right? So you could have pretty much achieved the same thing with baking the agent onto the box and a little bit of AutoSign. You can pretty much achieve the same outcome, and I'm sure plenty of people in the room have done that. So the real trick, like we said, is actually not on the way up, it's on the way down, is understanding the life cycle of the nodes, whereby a node's been terminated out of band. Puppet doesn't know about that out of band termination, but Amazon's going to notify you, I've terminated this node, I'm completing its life cycle, and then we're basically picking up that message and notifying the Puppet master saying, this node will never come back to you ever again, I want you to clean it out of the master. So this is the tricky bit, really.
I guess the point there is as well that you've now got the master in the way. It's able to check state on applications deployed. It may not necessarily actually deploy the applications. So we might have actually baked the application in, and it might have just started up. But we can still apply manifest to make sure that we're compliant. So we can have a compliance module on there. And that's what some of the organizations want. Even though the instance might be an hour, it might live for an hour max, they still need to prove that it's compliant while it was in its life cycle. So what we're going to do now is just basically take the desired capacity back down to 4. Amazon's going to delete those instances and send notifications to the SQS service, and the broker will collect those and delete them, revoke the certificates out of the dashboard, and clean the reports. So just go back over to our view here. You should see desired capacity 4 at the top, so it's gone from 8. And you'll start to see they'll go and change state to shutting down.
So the reason this is important is the fact that Amazon, again, as an out-of-band function, something that Puppet doesn't understand, Amazon's just going to randomly pick which nodes it wants to terminate, right? That's how the auto-scaling stuff works. There is some logic around that, but it's basically saying, I'm going to get 4 of those servers and I'm going to axe them in the head. And obviously, we're just going to complete that all the way through to the Puppet master. So they're now shutting down. So wait till they get to terminated. Once they get to terminate, you'll basically see, so there you go. So 2 have gone to termination. So if we look through the logs, on the next tab. So it's now cleaning itself out of the master.
Yeah, and the same thing. So once the broker sees that there's a lifecycle event on terminate, it's going to reach out through the API and see if there's a node that matches that. And if there is, it's going to do a bunch of activities. And here it is deactivating, revoking the certificate, and cleaning the reports. Once it's done its job, you can see it's deleting the message from the SQS service, so it won't try again. So if I reload the console, we should go back to 4 nodes. Go back to 4 nodes. Okay.
Everyone loves demos, right?
Back in the room.
Well, that was a demo. Yay, that worked.
It's not production grade yet. Okay. Yeah. Takeaways. We can now use the Puppet Master as a central point of control. We can build transparency and application state across our transient compute and our long-lived compute. This means we can give PuppetDB and all the other instrumentation we've got for the other long-lived instances. We can merge that data in. We can get a holistic view of what's going on in the environment and what kind of compute we're leveraging. Also, AWS really has a powerful orchestration engine built in, and we can tie that in with the Puppet Master and give it some awareness of what's going on behind the scenes.
So just stepping through the netbook, so we're going to take a look forward, and of course, as with any look forward, it's an interesting landscape at the moment, having a look at what's going on. So what we've really been talking about now is we've basically made the Puppet Master aware of out-of-band Amazon activities. We've worked out a way to scale Puppet Masters globally across the planet, and we've also worked out, how to put, or educate Puppet on what Amazon's doing above it around the application ownership, right? So we can still be the primary governance engine, so your regulatory bodies can come in and say, yes, you're fully compliant, but it's not necessarily involved in every single piece of that transaction. So the second really big thing that's happened is obviously that's kind of where we're at the moment, but I think there's another real key shift in the IT industry at the moment, and that is that, what this is based around is I get some infrastructure, some servers, and I put Java on it, and I have to define what Java is and all that kind of stuff. And then the application comes on and consumes that as a service. I think there's obviously a real push towards moving that bar of standardization higher, whereby me as a business user, me as a consumer, I don't actually really care about the servers or the networking. What I really care about is getting a hold of Java, right? That's ultimately what I want, is I have some code and I want some Java. That's really what the lifecycle would look like as a consumer, as a business user. So the bar of standardization is very rapidly, moving up. And that's really had an impact on the business. So what they're doing is they see this as such a fundamental shift to the way they deliver applications. They're really getting like IT, like as a low-value function, they're getting IT out of the way, and they're basically just, here's my app, deploy my app, run my app, right? That's all that they care about. And they're willing to modify their applications in order to do that. So instead of basically, this is the high-level statement, is instead of making the OS a good candidate for the applications are tailoring themselves to live and work inside these standardized runtime environments. Right? And those runtime environments are being put on really standardized infrastructure, because that's basically what the cloud platforms are really doing. Now, obviously, it's a very wide space right now. There's a lot of technologies in here. It's really healthy. There's a lot of innovation in this area going on. So we're not trying to like this tech or this tech or this platform. The point is that Puppet can orchestrate a whole number of these platforms, right? So it doesn't really matter which one you're picking. It's the fact that we need to get these frameworks. And we need to still govern them. So if you're going to use Puppet or you're going to use OpenShift or whatever you're going to use, we still fundamentally have to govern those platforms, right? So this is really like what the future step looks like. And then all we're doing is basically providing this standardized runtime environment and standardized runtime framework. And then the business users and the IT consumers, they're just sitting there and consuming that from us. So we still need to provide that governance to the business, is their runtime environments are compliant and are up to scratch with whatever regulations they're trying to achieve.
So this is one of the things we see going on right now with some of our enterprise clients. They've probably started with some on-site VMware, and they run it as a service internally. Then they're buying it managed from HP or Fujitsu or whoever else, and they're buying VMware as a service. And then they probably go down the route of stable compute in Amazon, and they play around with IaaS. And then they start to look at paths and how they can do Beanstalk and do their own CloudFormation-based frameworks. But if you look at all the target stated frameworks that live above this, so like Docker and Pivotal and all that stuff, it's kind of a multiplying effect. I mean, we've got to keep the governance across the whole plane, and we've got to try and maintain Puppet or a tool like it to have a ubiquitous view of what's going on, so we know what state and governance is happening across the whole board. And we see it as a kind of an exponential problem. There's cloud everywhere, right? We work with Azure, VMware, and some others right now. And ultimately the problem is it's becoming exponential. And the way to achieve that is to make sure that we do have a good view of governance across the board.
So what it really comes back to is it comes back to this problem space, which is we've got all these application delivery frameworks or runtime frameworks that are kind of exploding out in the industry, right? We have all these clouds that are exploding everywhere. We still have to govern them, right? And we still have to build out a model and a technology platform that's going to let us govern those particular platforms, because again, when the regulator steps in, they expect to see that data given to them at a moment's notice.
A lot of our customers want vendor arbitrage. And if you look forward and you think of this ideal world, if we get to the point where we commoditize everything to the bottom line, it would be great if we just use the CI tool and nothing else, the CI/CD tooling, and we're able to just drop our app onto Amazon, or drop our app onto OpenShift on Rackspace, or Docker on VMware, it's a managed service. If it's just that easy, the application portability is there, we should be able to achieve that arbitrage.
So what we're really talking about here, again, this was the future state, is that if we kind of wrap up the whole conversation here and wrap up the whole talk, so the first thing we started was we've basically got Puppet managing a site, so we have Puppet running. We've then obviously, with our first design pattern, talk about Puppet at a global level, so the ability to scale that out across multiple global regions. Okay. We've also now got not just global distribution, but we've also educated Puppet on how to run inside these clouds, and Amazon being the key service. So now at the point it's Puppet plus Autoscale awareness plus global distribution. Okay. And then of course we've talked about the fact, because Puppet has that platform and because it's sort of
agnostic.
Yeah, like it's agnostic. It doesn't really matter where it runs. We've obviously now got the ability to go Puppet plus Autoscale plus global distribution plus the multi-cloud, because all the CTOs want the multi-cloud. And of course, that comes back to the fact that it doesn't necessarily have to be cloud either. We've still got this fantastic framework that knows a hell of a lot about your data center. So this is really kind of like end future state is the application delivery frameworks being auto-scaled on any arbitrary cloud in any arbitrary global region. And that's kind of like a future thought, I guess, is where we're sealing the discussion up with that.
And we see the bar of commoditization rising all the time, and platform as a service is just another well-defined target state environment for your application to go into. But governance and compliance will always rule. And I guess that's kind of the closing thought is that we need to make sure that we can prove, again, when orders come through the door, that state is there and how things are configured. Even though the underlying infrastructure might be transient, we still need to prove how things were when it was running. And everyone's expectations of application delivery are keeping going up as well. So it's no longer weeks, it's hours or minutes.
Cool. So that's it, guys. Thank you very much.
I think any questions?
Yeah, I think it's open for questions, right? Generally. Yeah.
I just wondered if, so there was that recent feature that showed up where you can embed stuff into the X509 service now, and the master can look for that.
Yeah.
I wondered if you were thinking about leveraging that somehow.
Well, definitely. I think if you look back to how we did classification and we embedded node data inside of tags, Amazon tags, we can take that away, that reliance on a specific cloud. So this will only work when we have the tag there in Amazon, and we can bake that into the X509 certificate. Yeah. We can have that as a node classifier itself, so we can pass that back to the.
Well, it seems like then you could have the auto
Yeah.
on and
Yep.
be a little more
Oh yeah.
secure about that.
And ultimately, the process you saw there with the scaling broker, that was built before that came along. So
we
I think it's
actually
definitely a good way forward. We were just talking about that before.
Yeah, we were, so PuppetConf in Sydney was actually where they announced all the new cert signing stuff, and we were about to do the demo like 10 minutes later, and I went, damn it, So, anyway. So yeah.
Puppet Enterprise licensing seemed a little confused there. You started your demo at 7 licenses used, and after you reclaimed your fork, it said 9 licenses.
I think it's
there's a few certs.
yeah, and I think also it takes a little while for the licensing engine to take around and work out what's going on. We've just basically used the API to pull out those instances from behind the scenes, and the licensing engine will just need to poll again and work out what's going on.
There are a few actually. There's a few things in the master that are signed on the back end there that are populating that license field as well, just for that demo platform. Yeah.
Any other questions?
Cool.
All right.
All right. Thank you very much, guys.
Yeah, thank you.
Really appreciate your time.